Read the numerical. A motor van weighing 4400 kg moves around a level curve of radius 200 meter on an unbanked road at 60 km per hour. What should be the minimum value of coefficient of friction to prevent skidding, and at what angle the road should be banked for this particular velocity? So there are two parts. First is a condition where it is not banked, you have to find out the coefficient of friction. Okay, when there is no banking, you have to find out coefficient of friction. And second is you have to consider that suppose if this coefficient of friction is not there, means we don't want to depend on this, then by how much the road should be banked. Okay, because the maximum safe velocity also depends on the angle of banking. So in the first condition there is no angle of banking, and in the second condition they are telling us find out that particular angle of banking for which this vehicle will safely move with this velocity of 60 km per hour without considering friction. That is the second part. So going to the first part, unbanked road, no banking. You can see there is a curvature road over here. This is just for reference I have drawn. You need not draw this diagram in your board exam, just for visualization I have considered. So this is the curvature of the road. The radius of curvature of this road is given to us, r is given to us, that is 200 meter. The mass of this car is given to us 4400 kg. Okay. So suppose if it is moving with some velocity, let's say it is moving with this velocity which is given to us 60 km per hour. Okay, it's moving with this velocity of 60 km per hour. Then in that case, firstly, what are the forces acting on this vehicle? As this vehicle is in dynamic equilibrium, the forces whichever are acting would be balanced. So let's visualize what are the forces acting on it. If I consider this is the CG, center of gravity for the vehicle, firstly there is a weight which is acting in the downward direction represented as mg. There will be a normal reaction which will be perpendicular to the road surface acting upwards. To every action there is an equal and opposite reaction, third law of Newton. So normal reaction will be acting in this direction opposite to the weight, equal to the weight. There will be an outward force which will try to throw the vehicle outward, the centrifugal force represented as mv square by r, and there will be a frictional force which will be inward, the real centripetal force, which will try to stop the vehicle from slipping outwards. Now, if it is in equilibrium, if this condition is in equilibrium, then the horizontal forces balance each other. Means the frictional force is just equal to the centrifugal force. Okay, but friction by definition is written as mu coefficient of friction into normal reaction, which is equal to mv square by r. Okay. Now look at the diagram again. From the diagram we can see that the normal reaction is equal to the weight. So over here this normal reaction over here can be written as mg. So if I just write that, I get mu mg is equal to mv square by r. If I cancel this m on both sides, what I conclude is the coefficient of friction is equal to v square upon, this g will go on the other side, v square upon rg, and this is your formula to find out the coefficient of friction. Okay, which you can start directly by using this also. You already know, if you have done your derivations well, for a flat circular road, if there is only friction and there is no banking, then the maximum safe velocity is given as v is equal to root of mu rg. So then what is mu? Mu is equal to v square by rg. You can directly take this and start. Or if you forgot this formula, then only I have given you over here a visualization as into going into the depth of the condition, understanding the whole situation, understanding what forces are acting on it, balancing the forces, equating them and deriving the equation. So if you don't remember the formula, then you go by this condition. If you remember the formula, then you start directly v is equal to root of mu rg. So in this case mu is equal to what? V square by rg, and then you just substitute the value. So here v is given to us as 60 km per hour, converting into meter per second. So multiplying by 5 by 18, I'll keep it as a ratio. It comes out to be as 50 by 3 meter per second. Okay, so that is the value of velocity. So velocity is given to us as 50 by 3 meter per second, and the radius of curvature is 200. Acceleration due to gravity, I'll take it as 9.8. So it becomes 50 by 3 the whole square upon 200 into 9.8. Solving this further and then taking a log calculation, your final answer of the coefficient of friction comes out to be as 0.1417, and this is your answer. Clear? Now this is only the first part, that is what should be the minimum coefficient of friction. Now what they are saying is, in the second case they are saying that don't consider friction, consider banking, and find out what is that angle of banking for which with this 60 km/h speed the motor van goes safely. So going to the second part of the sum. The second part of the sum, it says that at what angle the road should be banked. So I have already banked the road. Okay, I need to find out what is that angle. I don't know what is that angle. Okay, now what are the forces acting on this vehicle? So if I just again consider the center of gravity, okay, and I resolve the forces, the first thing I understand is the weight which is going to act vertically downwards. Okay, the normal reaction which is going to act in the direction perpendicular to the road surface. So this is the normal reaction. Is there any friction? Is there any friction? No. It was there first. Okay, the first part of the sum was what should be the minimum friction so that it does not skid. Now they are saying is that consider that there is no friction, and in place of friction I want to replace banking. Then how much should it be banked? So in the second case they are saying neglect friction. That is what they are meaning. Okay, suppose if friction is to be neglected, then how much the road should be banked? So friction is not there. Okay, and according to this banked road, there is one more force. Since it is moving along a circular path, there is a centrifugal outward force acting over here, represented as mv square by r. If I resolve this component over here, normal component, then according to the similarity, this angle, okay, and this angle would be same. So this would be theta, this would be n cos theta, this would be n sin theta. Okay, since it is in equilibrium, the horizontal and horizontal forces are equated. So I get it as n sin theta is equal to mv square by r, and the vertical and vertical forces are equated. So we get it as n cos theta is equal to mg. If I divide these two equations, okay, what do I get? N gets cancelled. Sin upon cos is what? Tan theta is equal to mv square by r upon mg. Gets cancelled. I get v square by rg. What do you need to find out? That angle of banking for which the velocity of 60 km/h the vehicle is safe. So velocity I know, radius of curvature I know, g I know. I want to find out what is the angle of banking, and this is your final formula. So you can start right away with this formula over here. I considered this diagram only to visualize and make you understand that you can always, if you forget the formula, you can apply your logics and get your formula back again. So you have got this condition, and now we start. Now we know the velocity. Velocity over here is how much? Yes, we had found out, no? It was 60 into 5 by 18, which came out to be 50 by 3 meter per second. So I substitute over here 50 by 3 meter per second square upon rg. R is how much? 200 meter. This is r. 200 meter, and g is 9.8. Finally, when you solve this, you get it as, with log calculation of course, you get it as 0.1417, that is tan theta. So what is theta? Theta will be tan inverse of 0.1417, and then in the tangent table, looking at the tan inverse part, you have to look in for what angle, degree and minutes corresponds to 0.1417. Finally, looking into the tangent table, we get the answer as 8 degree and 4 minutes. So this is the angle of banking for this particular velocity, okay, for the vehicle to safely travel. And this is the second part of the sum. I hope you are clear.